Let's take a look real quick at factoring polynomials that happen to be quadratic trinomials where the leading coefficient isn't 1. These are going to see take a little bit longer to do than when our leading coefficient is 1, but they're not too much more difficult. Let's look at our first example here. As always, we want to see if we have a greatest common factor that can come out of all three terms, and in this case we see we don't. Nothing goes evenly into all three terms. So we're going to go straight to our AC method. We're going to do 8 times negative 3, our A is our leading coefficient, C being our last term here, which gives us negative 24, and we're going to use our B as well, the positive 2. So we'll be looking for the two numbers that multiply together to give us negative 24, but add up to give us this 2. Thinking about it for just a second, we can see that those two numbers that work here would be 6 and negative 4. Now if we were using this method when A was equal to 1 instead of 8, we'd be pretty much done. Our answer would be x plus 6 times x minus 4. However, we can see here that if we were to distribute that back out, it wouldn't give us our 8x squared, it would just give us a 1x squared. So we know that can't possibly be our answer. What we're going to see here is that when A is not equal to 1, these two numbers, the 6 and the negative 4, are going to be used slightly differently. They tell us how to split up this linear term to get us on the right track. Instead of writing plus 2x, we're going to write our linear term as two terms. We're going to use plus 6x, the 6 from our number 6 we came up with, minus 4x, the minus 4 from the negative 4 as our second number. The rest of the polynomial we can just leave as the same, just copy it down. Now what this allows us to do, since it's 4 terms, is we can group the first two terms together, so we'll group up 8x squared and 6x using these parentheses. We can group our second two terms together, the minus 4x minus 3. So now we have two binomials all grouped up. We're going to take the greatest common factor out of each group. So looking at our first group, the greatest common factor would be 2x. We'll have some left over here in a second. In our second group, we can see the only thing that can come out of both terms is a negative 1. Whenever your first term in a group is negative, you always want to take out some sort of negative number, even if it's just negative 1. Looking at what's left over here, after we factor out, we should have 4x plus 3 in the first group, and 4x plus 3 in the second group. You know you're doing this right if you get to this point and these two kind of leftovers match up. If they don't match up, it means you either didn't take out the greatest common factor, maybe you forgot to take out a negative when you're supposed to, or you just made some silly mathematical error along the way. But these should always match up. When we get here, we can see that these two terms are exactly the same. Well, we have two factors that are exactly the same in our terms here. It might not look like a greatest common factor, but it is. It just happens to be a binomial. So we treat it just like any other greatest common factor. It comes out front. So the 4x plus 3 comes out in front. If I took a 4x3 out of this first term, all I'd have left over is this 2x. If I took a 4x plus 3 out of the second term, all I'd have left over is this minus 1. And that's our answer. We can double check through the distributive property that we did this correctly. 4x times 2x is 8x squared. 4x minus 1 is minus 4x. 3 and 2x multiplied together gives us our plus 6x. 3 times minus 1 is the minus 3. This should look pretty familiar as our row right here. Combining up our like terms, we'll see 8x squared plus 2x minus 3. This kind of checks out as our trinomial that we started with, so we know it factored it correctly.